Okay guys, 19.3. So 19.3 is going to focus solely on reading the problem and then writing a system of equations. And occasionally we might try to find a solution, but really the focus is defining the variables and writing the equation. All right, so we have a new bike and skateboard problem. Uncle Eddie asked McKenna and Lara to order 108 new wheels for the 42 skateboards and bicycles in his repair shop. How many bicycles and how many skateboards are in Uncle Eddie's shop? Okay, so record your work and your solution to the problem in the space provided here. So the first thing that we need to do is we need to define our variables. We should always be doing that first. So we need to define what X and Y are. And X and Y are going to be whatever you're being asked to find. So for this problem, I'm going to label X the number of bicycles and Y the number of skateboards, because those are the two things that we're being asked to find. And this is not the first type of problem that we've done like this. We have done several bikes and skateboard problems. So we know a couple of things before we write our system. We know that there are 108 wheels and that there are 42 skateboards and bicycles altogether. So one of our equations is going to deal with the number of bikes and skateboards, and the other one is going to deal with the number of wheels. Okay, so we know that the number of bikes, which is X, plus the number of skateboards, which is Y, we know that that has to equal 42 vehicles. Okay, we also know that the number of wheels total 108. And from previous problems and just from knowledge outside of math class, we know that there are 2 wheels for every bike and 4 wheels for every skateboard. And when I total those all up, I need to get 108 wheels. Okay, so we're also being asked to solve the equation, and we are gonna solve it, but I'm gonna let you use Desmos for this, so we're gonna use a graph. So I'm gonna pull Desmos up here, and we're just gonna use a graph for it. So I'm gonna type in my first equation, X plus Y equals 42. And my second equation, 2x plus 4y equals 108. Okay, so if I go over here and I find my intersection is 30, 12. So let's get back into our notes here. And I have my 30, 12 as my solution, and then we are being asked to show how we know that that's correct. So the way that we have to do that, remember, we're going to plug into each equation. So I'm going to start with X plus Y equals 42, and I'm going to substitute 30 in for X and 12 in for Y. And then I'm going to calculate. So 30 plus 12 is 42. And that equals 42, which is what we wanted. So I'm going to check that off because that is correct. All right, I'm going to also check my second equation. So I have 2x plus 4y equals 108. So I am again going to plug in 30 for x and 12 for y. Okay, if we do 2 times 30, we get 60, and 4 times 12 is 48. And when I add those two together, I do get 108. So my solution does work, and it works in both equations. So that is our explanation. How do we know? Well, we explained with our algebra, but we can also state that 30, 12 works in both equations. Oops. Okay. Right, and that's what we're doing today. So we're just gonna write Solve, check. If it asks us to. It doesn't ask us to check in every single example, but you should be in the habit of checking things out. All right, next problem. The movie and game rental problem. And this is an important one. This one's gonna come back later in, I believe 19.5. So in lesson 5, we'll come back to this one and solve it. We're not gonna solve it right now. So the Lupines family of werewolves are heading off for vacation in the woods of Transylvania. Uncle Harry Lupine has rented a total of 12 horror movies and gory games on CDs to amuse the kids. Freddie and Lenore on the trip. They want to know how many games and movies they have. Uncle Harry wants Freddie and Lenore to do some math on the trip, so he tells them games rent for $4.50 each, movies rent for $3.99 each, and the total was $49.92. Now, can you figure out the answer? Okay, so we're gonna go through the steps again. First step, describe the situation. What are we trying to do? What are the facts? Okay, so we are trying to find the number of games and the number of movies. And what do we know? So we know that there are 12 total items. We know that he spent $49.92. And we know that the games are $4.50 each. And movies are $3.99 each. Okay, so we know quite a bit of information here, and we are just going to go through these steps and write our system. So we're going to start by defining our variables. So what do we want to make x and what do we want to make y? So let's make x the number of games. And let's make y the number of movies. And we're going to put that into a system. Okay. So our system, we have to have an equation for each one of our restrictions or restraints, as we've been calling them. So we have 2 restraints. We have 12 total items, and we have a total cost of $49.92. So one equation has to deal with the total items, which is 12. So if I take the number of games plus the number of movies, that has to equal 12 total items. My next equation has to deal with money. So I know that my games are $4.50 each. So $4.50 times the number of games plus $3.99 times the number of movies has to give me a total cost of $49.92. There is our system. And we just need to explain why we call this a system of equations. Okay, it is a system because it consists of 2 equations with 2 variables. And that is just straight from your definition of a system that we came up with the other day. So that's nothing new. That's just asking you to repeat the definition in your own words. All right, we got one more that we're going to go through, and this is the swamp problem. So on their vacation, the same family stays at a hotel that has a rectangular swamp for a swimming pool. Uncle Harry gives Freddie and Lenore a new problem to solve. Suppose the swamp has a perimeter of 124 feet. The length of the swamp is 10 feet less than 5 times the width. what are the length and the width of the swamp? So let's go through this just like we've been going through it before. So let's start with step 1. We know that the perimeter is 124 feet, and we know that the length is 10 less than 5 times the width. There's some other things that we know. We know that perimeter is 2 times the length plus 2 times the width. And in case you didn't know that or remember that, there it is. And we also know that we are looking for the length and width. Okay, so that is our step 1. Okay, step 2, we are going to assign our variables. So we know that we're looking for the length and the width, and they really tell us that L is length and W is width. So that's given to us in the problem. We didn't have to come up with our own variables, but if we did, we know how to. Okay, the third step is just to write our system of equations. Okay, so we have 2 restraints here. We know that the perimeter is 124 feet, and we know that the length is 10 less than 5 times the width. So really, our equation for perimeter is a formula that we've used for many years. 2L plus 2W has to equal 124 feet. Okay, so that takes care of our perimeter restriction. And then we also know that the length is 10 less than 5 times the width. So I'm going to do 5 times the width and then take away 10. And that is our system of equations. Now, as we move forward into lesson 4 and 5, we're going to work more with solving. But for today, it's really just about writing the system.